The process of converting addresses from key is called hashing, and the array in which insertion and searching is done through hashing is called hash table. Is called as hash table. So the process of converting addresses from key is called as hashing, and the array in which insertion and searching is done through hashing is called hash table. So we have hash table with us. So first of all, we will talk about hash function. The criteria for choosing a good hash function is it should be easy to compute. Next, it should generate addresses with minimum collision. So what is the minimum collision? If two key value have the same hash function, so this is the condition of collision. Two keys can never have the same hash value, but it may occur in today's scenario. So what we will do, we will apply some collision resolution techniques to avoid this situation. So it should generate addresses with minimum collision, that is it should distribute the keys as uniformly as possible in the hash table. So it will the keys are distributed uniformly. So how these hash values are generated, how the addresses we have generated the address, let's take a look. First method is truncation. Or we can also call this as extraction method. Here we take only part of a key as address. We'll take only part of the key as address, that is, we may take some rightmost digit, or some leftmost digits. We can take some rightmost digit, we can take some leftmost digits, right? So let's take an example. Let's suppose we have 82394561. So this 61 is the hash value of this particular key, right? We have 87139465. So this 65 is the hash value. Hash value is 65, right? The chances of collision in this particular scenario is more. The chance of collision in truncation is more because two keys can in any case have same hash value. So the chances of collision in truncation method is more, right? Next is mid-square method. Next method is mid-square method. Next is mid square method. The key is square. The key is square and some digit orbit of the middle of this square are taken as address. So the key is the square and some digit orbit of the middle, which we are just squaring the key value, and then we are taking some digits from the center, some digit orbit from the center. Let's take a look what we will do. Let's suppose we have key with us 1337, 1273, 1391. We have these three digits. So the square of the key would be 1787569, 1820259, and the square of this is 1052676. So this is the square. So we are taking the leaving the first two digits and taking this. So this is the hash value. 875, 202, 526. So leaving the first two digits, we are taking the next three digits as the key value in mid square method. Chances of collision is also not so many highs as that of the case of truncation, but chances of collision are also there in this case. Next comes the third method is folding method. Next is folding method. What we are doing in folding method, the key is broken into, in this case the key is broken into different parts. The key is broken into different parts where the length of each part is same as that of required address, except possibly the last part. Next point in this case is, after this, these parts are shifted. After this, these parts are shifted, such as the LSB of all parts are in same line. And then these parts are added, and you can ignore the final carry. In the third step, you can ignore the carry. Let's take a look how we are doing this folding method, how we are calculating. Let's suppose we have key with us 73823, 945 and 6527. So we have divided this key value into parts, that is 738, then 239, then 456, and then 527, right? So what we are doing, we are just add up these values. We add up this is 960, 1960. We can ignore this final carry. So the hash value is, or you can say hash address is 960. This is also called as, this is also a technique called as folding method. So there is another technique which is called as shift folding method. Next technique is shift folding method. What we are doing in shift folding method, let's suppose we have the same key 7, 38, 2, 39, 4, 5, 6, 5, 2, 7. So first value we are taking is 738, next we are swapping it 932, next we are taking 456, next we are taking 725, the reversal of this. Now we add up this, we are ignoring this carry, and the hash address is 851 in this case. The hash address is 851 in this case. Next comes division method. Next is division method. The key is divided by the table size. The key is divided by the table size, and the remainder is taken as the address. And the remainder is taken as the address. The key is divided by the table size, and the remainder is taken as the address of the hash table. Right? We are dividing the key with the table size, and the remainder is taken as the hash address. So the formula of this is h of k is equivalent to k mod m. This is the formula to find out the hash address through division method. Collision is minimum in this case when the table size is a prime number. When the table size is a prime number, in that case only we have minimum collision in this case, right? Next is collision resolution technique. Collision resolution technique. Collision resolution technique. So when the two key have the same hash address, how we will resolve this collision? So we have some collision resolution techniques. So very first collision resolution technique is open addressing. Open addressing is also called as closed hashing. First is open addressing, which is also called as closed hashing, and next collision resolution technique is separate chaining. Next collision resolution technique is separate chaining, which is also called as open hashing. Right? So first we will talk about open addressing, which is also called as closed hashing. So in this we have many techniques. First is linear probing. First is in open addressing, closed hashing, we have many techniques, and first technique is linear probing. Let's suppose we have a table size of 11. And what we will do? We will form the key mod table size. So let's suppose the values are 29, 46, 18, 36, 43, 21, 24 and 54. Hash value, we need to compute the hash value of all the elements. So hash value of 29 is 7. This is 2. This is 7. This is 3. This is 10. This is 10. This is 2. This is 10. So there are collision in these three. We have collision in these two, and we have collision in these two. How we will resolve the collision? We have a formula of collision resolution. that is k comma I is equivalent to h of k plus I mod table size. This is the formula we have to avoid the collision. That is, if we have a table with us from 0 to 10 index, right? If first 7th 1 2 3 4 5 6 7 8 and we have 9 with us and we have 10 with us, right? So this is 10, this is 9, this is 8, this is 7, this is 6, 5, 4, 3, 2, 1, 0, right? So 29 is placed as 7th location, 46 is placed as 2nd location. Now 18 is placed at 7th location, because what we will do, 7 plus 1 mod table size. So 8th location is the place for 18. 36 placed as 3rd position. 43 is placed as 10th position. 21 is placed at 10 plus 1, 11 mod table size, that is equivalent to 0. So next 10 would be placed at 0th location, right? So what we are doing, h of k plus 1. Then if they in that location also collision, then 2. In that location also collision, then 3. So we will put the value of I from 0, 1, 1, 2, 3, right? So we are putting the value of I from, first we will put the value of I as 1, then 2, then 3. If there is no collision, we will place the value. Next comes quadratic probing. Let's suppose we have a table size of 11. And we need to place some values. So in quadratic probing, the formula of new hash value is equivalent to k comma I is equivalent to h of k plus I square mod table size. So let's suppose we have values like hash of 46, hash of 28, hash of 21, hash of 35, hash of 57, hash of 39, hash of 19, hash of 50. We have these values. What is the hash value? This is 2, this is 6, then 10, then 2, 2, 6, 8, 6. So how we have computed these hash values? These hash values are simply computed from h of k mod table size. But because the collision resolution formula is this one. So these values are simply stored. So now there is a collision at this. So 35 is placed at which location? H of k plus 1 square, that is 3. There is no value that is at 3. So 35 is placed at 3rd location. Now there is a collision, 2 plus 1 square collision, 2 plus 2 square, 4, 5, 6 collision, 2 plus 3 square, 9, 10, 11. 11 is not a place. 11 mod 11 is 0th. So this is 0th location. This 57 is placed at 0th location, right? Because 2, 9, 10, 11, 11 mod 11 is nothing but 0. So this is the place for storing this 2, this 57. Next 6, there is a collision, 39 plus 1 square. Oh sorry, 39 is 6, 6 plus 1 square, that is 7. 7 mod 11, 7, there is no collision. So it will be placed at 7th location. 39 is placed at 7th location. So in this way, we have resolved the collision in this case. Next, after linear probing and quadratic probing, we have another method that is called as double hashing. In double hashing, the increment factor is not constant, but it depends on the key. The increment factor, another hash function, and hence the name double hashing. We are doing double hashing in this case, hashing on the above the hashing, right? So what is the collision resolution formula in this? H of k comma I is equivalent to h of k plus I h dash of k mod table size, hk plus I of h dash k. So we hk, all we know that this is nothing but key mod table size. This is, we all know that hash value of k is key mod table size. What is h dash k? H dash k is nothing but 7 minus key mod table size when the table size is 11. So in this case what we are doing? We are just doing 7 minus key mod table size when the table size is 11. So similarly we can easily compute the different hash function for this particular problem. So let's suppose I'm taking an example. Let's suppose we need to apply h of 46, h of 28, h of 21, h of 35, h of 57, h of 39, h of 19 and h of 50. So what are the hash values? Simple hash values: 2, 6, 10, 2, 2, 6, 8, 6, right? We have simple hash values. So there is no collision, no collision, no collision, there is a collision. So how we will resolve this collision? Hash value of 2 plus 1, new hash value 2 plus 1, which is h dash of k. H dash of k is 7 minus, what is our key? 35. 35 mod table size is 2. 7 minus 2 is what? 5. So 2 into 5 mod table size. So that is equivalent to 7 mod 11. That is equivalent to nothing but 7. So the hash value of this is 7. Right? Now we have collision with us here also. So first hash value is 2. There is a collision. Now we will apply this I h dash k. That is also collision because that is 7 already computed at this step. Now we will use I is equivalent to 2 in this case. So hash value of this plus 2 into 5. We have 5 with us through this hash dash k, and then mod 11. So 10 plus 12 mod 11 is nothing but 1. So the hash value of this is 1 in this case. Right? Similarly for this collision and similarly for this collision, we can resolve using this formula when we have h dash k as 7 minus k mod 11. Right? Next comes separate chaining. Next comes separate chaining. In this method, linked lists are maintained. In this particular method, we have implemented a linked list as maintained for elements that have same hash address. Here the hash table does not contain actual keys. We are maintaining a separate keys for the hash value. In this particular case, we are maintaining the hash value as a linked list form. So let's suppose some keys has the same hash address 0, 1, 2, 3. We have 4 elements type 0, 1, 2, 3. So let's suppose 4900 as a 0 address and 65559 is also have the address 0. So we have maintained a separate linked list. Similarly with this case, we have 4911 and we have implemented a 4390 as the similar, and the hash value is created using simple key mod table size, and when we have collision, we have simply maintained a linked list form. Right? So this is all about hashing. Thank you for watching.